Hey everyone, welcome. In this video, I'll show you how to graph a quadratic function. So let's say we're given this function f of x equals x squared minus 2x minus 3. So instead of just picking some values for x and determining what's y and plotting it that way, we can be more precise and get our graph completed faster by figuring out these important points of interest: the y-intercept, the vertex, and the x-intercepts. X-intercepts are also known as roots or zeros or solutions even. So depending on how your math teacher describes it, you might hear those terms instead of x-intercepts, but it's all interchangeable for that. All right, so we've got these three things we want to plot. All right, let's start with the y-intercept. That's the easiest one because it's just what happens when x equals 0. So the function value at 0, well, this term zeroes out, and so does that term. So we're just left with f of 0 equals negative 3. So that's our point, 0, negative 3. So we can plot that over here, 0 for the x value, and then 1, 2, negative 3. All right, the vertex, we'll want to get our x and y value for that. Now, one thing that's helpful when you're working with quadratics is to list out your coefficients, a, b, and c. This will be helpful not just for the vertex, but if you're doing the quadratic formula. So our coefficients here, a equals 1, b equals negative 2, and c equals negative 3. So for calculating our vertex, we can use this formula x equals negative b over 2a. So that's negative 2 over 2 times 1, just using these values. So that'll be 2 over 2, which equals 1. So the x-coordinate of our vertex is 1. Now to get the y-coordinate, we're just going to plug in what we got for x, that 1, into the original equation. In other words, it's f of negative b over 2a. F of 1 for this equation gives us 1 squared minus 2 times 1 minus 3, which is 1 minus 2 minus 3, which is 1 minus 5, which gives us negative 4. So 1, negative 4 is our vertex. And we can plot that. 1, negative 4 right there. And our x-intercepts, also known as the roots or zeros. So, and also I mentioned also known as solutions of the equation, of this original equation. So basically, for those x-intercepts, you're just going to solve this for x. So we can set it equal to 0. It's an easy way to look at that. And this equation does factor. If it didn't factor, you could use quadratic formula. So we factor this. So x times x to give me x squared, and then the only factors of 3 are 1 and 3. And I know that the 1 has to be positive, 3 has to be negative. So the solutions there are x equals negative 1 or x equals 3. So I can plot those. Negative 1, x equals negative 1, and x equals 1, 2, 3. And so I'll list those as negative 1, 0, comma, and 3, 0. So now I have these important points of my parabola, so I can just come in and just lightly sketch it in there. So if you have a little hesitancy about drawing a smooth curve right off the bat, just kind of sketch it in, ghost it in, and then come back and go over it. So we've been working in this case with our original equation, f of x equals x squared minus 2x minus 3. We found these important points and we graphed it. Now sometimes you'll see a different form of the equation, or you'll be asked to convert something like this to vertex form. So let me show you what that's about. Okay, so here we've got This is the equation we've been working with right here, and the general form of that is ax squared plus bx plus c. You can convert this into a format called the vertex form, which is f of x equals a times x minus h quantity squared plus k, where hk, these guys here and here, give us the vertex. So how do you get this form of equation into this form? So you'll use completing the square, but in a slightly different format than when you complete the square to solve for x. What we're going to do is rewrite this and group the terms with x together and leave a space here, and then we've got this minus 3 outside. So what are we going to do in here? Well, just like other forms of completing the square, we're going to add something here, but then to make up for it, we have to subtract that same something out here. So let me sort of reinforce that we're adding something here, and then we're making up for that by subtracting it out here. So we have to do that to keep the equation true. All right, what do we add here? We're going to take half of the coefficient of this middle term, and then we square that. So half of -2 is -1, and then we square that. So that just equals 1. So we're going to add the 1 there, and then we're going to subtract it right out there. We can rewrite this, the x squared minus 2x plus 1, as x minus 1 quantity squared, because we forced it to be a perfect square, so we can rewrite it in that form and multiply that out for yourself if you'd like to convince yourself. And then out here we have minus 4 when we combine those. So notice this is our h and this is our k. So that gives us 1, -4 for the vertex, and that matches what we found here when we did the problem this way. That 1, -4 right there is the vertex. So that's a look at graphing a quadratic. Make sure you show all these things on your work, and if you need to convert to vertex form, this is the method to do it. And as always, thanks for watching.